welcome to today's webinar, Python for Machine Learning. Today's webinar is going to be really a tutorial on Python in the context of machine learning. So I'm going to start with a very brief introduction to Python, then an even briefer introduction to machine learning. Today's webinar is by no stretch of the imagination a tutorial on machine learning itself. And then for the main content of the webinar, I'm going to give a mini tutorial on Python and then talk about NumPy, which is a particular Python package. So overall today, I'm going to be focusing on the parts of Python that will be of particular interest to you if you're interested in learning about machine learning. So let's start by taking a very, very quick look at Python itself. If at any stage during this webinar you want to ask any questions, feel free to type those questions in at the GoToWebinar control panel and we'll have staff on hand to answer your questions as we go along. So let's start by saying a few things about Python. Python is a general-purpose programming language. It's an interpreted language. It's a very compact language. And Python code is very readable. It's often compared to pseudocode. A Python program looks a little bit like an English language description of the program itself. Python is very quick and easy to learn, and it's also very quick and easy to write. And Python is sometimes described as being a very high-level language for that reason. Python has rapidly become a very, very popular programming language because it's actually quite a beautiful language in its own right. People get very enthusiastic about Python. The place to go if you want to find out all about Python is the website python.org. There you'll discover that Python has a relatively small, compact language. Built around that language is a very extensive standard library. So any of the normal capabilities that you'd expect of any programming language can probably be found in Python's standard library. And then built around that again is a huge collection of third-party packages in Python. I'll say more about those in a few minutes. So we have a very small core language, then a much larger standard library, and then an enormous collection of user-contributed packages that make up the Python world. Technically, as a programming language, Python supports dynamic typing. It's an object-oriented language from the ground up. So in Python, every value, every function, and every class is actually an object. Python also includes many functional programming features, and it supports metaprogramming. In other words, you can use the Python language to extend Python itself. And Python can also be extended by writing new modules in C or C++. In fact, a number of the third-party packages that have been contributed to the Python world are actually implemented in C and C++. So python.org is the place to start if you want to know more about Python. There you can download Python implementations, you can find all the Python documentation and tutorials, you can find all of the third-party packages in PyPy, and generally join in with the Python community. You can download Python itself from python.org. There are Python implementations for Windows, for the Mac, and for other platforms, which actually refers to all of the Linux implementations. And you'll immediately discover that there are two different versions of Python kicking around, Python 2 and Python 3. So the first immediate question to ask is, which of them should you use? Well, the short answer is that Python 2 is now history and Python 3 is current and the future. Python version 2 is now obsolescent. Python 2 will formally be killed off in 2020. So if you're starting to write Python today, you should start writing in Python 3. Python 3 is the version of Python that you should use going forward. Unfortunately, Python 2 and Python 3 are not compatible with each other. And unfortunately, if you start using Python today, you're soon going to be bumping into legacy packages written in Python 2. That's exactly what will happen if you start using some of the common machine learning frameworks that still make use of Python 2. So unfortunately, as of today, you really need to be familiar with both Python 2 and Python 3 and the differences between those two versions. The differences are not that great, and if you simply Google the differences between Python 2 and Python 3, you'll find many web pages dedicated to explaining to you all of the differences. I referred to the Python third-party packages. All of the third-party packages you can find through PyPy, the Python package index. Anything that you think you might want to do in Python as a programming language, any sort of programming language feature that you think you might need probably already exists in the standard library, and any kind of application that you think you might need, particularly if it's some sort of general purpose utility, will already have been implemented and will be available in PyPy, the Python package index. When it comes to installing standard Python packages, you do that using a utility called pip. So here, for example, we're doing pip install PySerial or pip install NumPy. When it comes to Python implementations, the Python reference implementation is known as CPython. That's the version of Python that you download from the python.org website. But there are many alternative Python implementations. You can find a list of all of the alternative Python implementations at this URL on python.org. There's also a large number of integrated development environments for Python available. That includes both paid for and free open source integrated development environments. And similarly, there's a wide range of free and paid for Python editors available. One of the most popular Python implementations is known as IPython, and this became popular a few years ago in the field of scientific computing and data science. More recently, IPython has been reincarnated as the Jupyter Notebook. Jupyter Notebook not only supports Python, it supports other languages as well. And I'll talk a bit more about Jupyter Notebook in a few minutes. One of the most popular distributions of Python is the Anaconda distribution. What Anaconda does is to package up in a single distribution not only Python and the Jupyter Notebook, but also NumPy, SciPy, Pandas, and a number of the other Python packages that are particularly popular for data science. Jupyter Notebook in particular you're going to bump into as soon as you start using Python for machine learning, because a lot of the machine learning tutorials and examples make use of Jupyter Notebook. Jupyter Notebook is a front end to a Python implementation that allows you to create a notebook that consists of documentation, fragments of Python code, and the output from the Python code. So within each Jupyter Notebook, you can use Markdown to create pretty printed fragments of documentation, then raw fragments of Python code, and as you execute that Python code, the output of the Python code appears there and then in line within the notebook. That's very neat. Anaconda I mentioned. Anaconda is a complete distribution of Python that includes Python, NumPy, Jupyter Notebook, and a number of other utilities, and you can download and get it running straight away on Windows or on Linux as well as other platforms. So that was a very brief introduction to Python. Now I'm going to be giving an even briefer introduction to machine learning. As you may have gathered, in this webinar, we're going to be galloping very, very quickly through Python and even faster through machine learning. What I'm really going to be doing is to give you a series of pointers or signposts as to what you need to know if you want to use Python for machine learning and where you need to go for further information. So this is going to be really useful. If you're interested in machine learning, you want to go and start grabbing and making use of all of the free resources that are out there right now for machine learning. As soon as you start doing that, you're going to find that a lot of the resources that are out there for machine learning actually assume that you already know Python. So what I'm trying to do in this webinar is to plug that gap and to give you some ideas of where to go next, exactly what you need to learn, and indeed hopefully provide you with a lot of that knowledge to give you a kickstart. So let's take a quick overview of machine learning. I'll just take as an example one of the most commonly referred to machine learning applications, which is using machine learning for classification. In the classification task, you start off with some sort of data set, might be images, for example, and each of the items in your data set will be pre-labeled according to what category that item belongs to. So the data that we're going to try and classify here is a set of images of cats and other animals. Each of those images is labelled, so we've got cat, dog, horse, and so on. And what we're going to try to do is teach a machine the relationship between the images and the corresponding labels. And we do that using a neural network. So the neural network is going to be fed the images, and for each image it's going to produce a score, a number, a real value that is associated with that particular image. The neural network actually calculates the scores by doing a whole lot of computation, and right at the heart of that computation are a series of multiply accumulate operations. What we then do is to compare the outputs from our neural networks, the calculated scores, with the labels, and as a result of that comparison, we produce some cost function. And during the machine learning process, what we're trying to do is to adjust the weights and biases at the heart of our neural network in order to minimize the cost function. So this comes down to a mathematical optimization problem where we're trying to minimize the value of the cost function by tweaking all of the weights and biases at the heart of our neural network, which is an extremely computationally expensive thing to do. The term deep learning, by the way, is applied when we've got a neural network that contains more than one hidden layer. So a neural network with 4 or more layers in total would be categorized as a deep neural network, and programming such a network by optimizing the cost function would be known as deep learning. There's a number of deep learning libraries or frameworks available. A short list of some of the more popular ones is shown here on the first line of this slide. I've picked out here 3 in particular because they're all particularly relevant to Python. So TensorFlow, which came out of Google, is really a back-end for a deep learning framework, which allows you to implement a neural network very efficiently, either on multiple or many-core CPUs or on GPUs. And TensorFlow natively uses a Python API. So although TensorFlow internally is implemented in some more specialized programming language in C++ or maybe CUDA for GPUs, the front end is simply Python. Keras is then a Python library natively written in Python that sits on top of TensorFlow and makes TensorFlow even easier to use. So Keras is a kind of application layer that disguises and hides some of the low-level details of TensorFlow. Cathay is yet another framework for deep learning. Cathay isn't natively implemented in Python, but there are a set of Python bindings for Cathay. So in all, if you start getting up to speed with deep learning, you're going to very, very quickly bump into Python, hence the motivation for this particular webinar. So when it comes to playing with machine learning for yourself, what you're going to want to do is to install one of these machine learning frameworks so that you can start using it. And there's a shortcut so that you don't even have to do that installation, which is to jump to AWS, Amazon Web Services, and use one of their predefined Amazon machine images that already have popular frameworks such as Cathay and TensorFlow and Keras pre-installed. I'm not particularly trying to advertise Amazon here. It's just a very, very convenient way to get started. What's even cooler is that Amazon now provide GPU instances. So within a few minutes, you can get up and running a pre-installed machine learning framework and have it running on a large GPU so that you can actually do all of the number crunching very, very quickly, which is just a really, really cool way to get started with machine learning. When you do that, here's a sample of some of the code that you might bump into in one of the web tutorials. This is actually a fragment of code from a Keras model. So what we're doing here is importing some predefined Python classes. We're building a neural network model, adding layers to form a logistic classifier, compiling those layers, having our model learn all of its parameters, and then evaluate the model to see how well it did. So here we've got some Python code. And what I'm going to try to do during the rest of this webinar is to help you become sufficiently familiar with Python that you'll have the confidence to start jumping into code like this and similar code examples I'll show you later, and start playing with these code examples for yourselves. So here we go. Let's take a look now at a mini Python tutorial. So Python is a programming language like any other. It lets you represent values. So in Python, we can write integers, floating point values, Boolean values, and notice that false and true are each capitalized. We can also have strings. And strings can be written either in single quotes or in double quotes, which can be really convenient. So suppose that you have a string that already contains some single quotes. If you choose to quote that string using double quotes, then you won't have to escape the single quote within the string. Comments in Python are prefixed by the pound or hash character. So pound or hash is a single line comment. A string can actually be written across multiple lines by starting or ending the string with 3 quote characters rather than a single quote character. You can see here that you can have either 3 double quotes or 3 single quotes. And a multi-line string can be used to write a comment. And there are a number of third-party packages around in Python for interpreting these multi-line comments as documentation. So you can have utilities that parse Python programs, find all of the multi-line strings, and then use that to build documentation for the Python program. Python has control statements like any other programming language. So we have if statements, for loops, while loops, break and continue statements. And one of the first superficial things you'll notice about any Python program is the quirky way it uses indentation. Within Python, indentation is a vital part of the Python syntax. The Python syntax doesn't include any end keywords. Instead, the actual beginning and ending of each block of code is determined using the indentation. This might seem really weird and quirky at first, but once you get used to it, there's a fair chance that you'll learn to love it. Most people start off by thinking, oh, this is a bit weird, but when they get used to it, it's actually really nice. The really nice thing about using indentation to determine the control structure is that you don't need to think about remembering all of those begin and end keywords and laying out your code properly. By the time you've actually got the beginning and endings of the blocks sorted out, the code is laid out properly, which is actually really neat. Python has the usual set of operators, most of which are borrowed from C. So the comparison operators, arithmetic operators, bitwise operators, assignment operators are all borrowed from C. The Boolean operators are the and, or, and not keywords, which are a little less quirky than the C equivalent. Then Python has for loops, as I've already said, so we might write something like for I in range, where range 4 is an abbreviation for the 4 numbers 0, 1, 2, and 3. So ranges will start by counting up from 0 by default, and if we write range 4, that's going to be a range of 4 values, 0, 1, 2, and 3. And we're printing out each of these values using the print function, which is a built-in function in Python. Python has many built-in functions and operators. This is just one example. And by default, the print function will write out its arguments and then write a new line character. But instead of using the new line character at the end of the print function, we can override that by using an argument to the print function, and that argument is named end. This is an example of a keyword argument. So when you call Python functions, you can either pass arguments into that function positionally or by using keywords. And keywords are often used to pass in optional arguments to Python functions. So here the optional end argument is being used to say, don't write out a new line character after the printed line, instead write out a space. So you can see here we've written 0 space, 1 space, 2 space, 3 space. We could start our for loop at a value other than 0 by passing 2 arguments to the range. So if we say for I in range 2, 6, we're going to have 4 values generated, 2, 3, 4, 5. So 2 in this case is the start of the range, 6 is the stop of the range. So the values in the range will start at 2 and will stop at 6. Which doesn't include the value of 6 itself. So as you can see here, with the values that are generated will be 2, 3, 4, 5. Again, this might seem a little quirky at first, but once you get used to it, if you're anything like me, you'll find that it actually comes very naturally. Python functions are very, very simple as well. Python introduces functions using just two keywords, def and return. So the def marks the beginning of a function definition. The return keyword is used to return a value from a function. So def add pqr is defining a function with 3 arguments. The colon, as in any control statement in Python, marks the start of an indented block of code, which is the definition of the function. Then inside the function, we're assigning a new variable temp, the value p plus q plus r. So p, q, and r are simply the arguments to the function. We're adding those 3 arguments together, calculating a new value. And in Python, all values are objects. As I said at the outset, Python is natively object-oriented. And then we have a new variable temp that's bound to that object. So in Python, variables are not declared explicitly, as in many other programming languages. Variables are declared implicitly the first time they're assigned. So this line of code, temp equals p plus q plus r, is implicitly declaring a new variable temp and binding that variable to an object, and the object is the object that results from evaluating this expression. Then when we say return temp, we're returning that object as the value of the function. And functions can be called within expressions just as in any other programming language. So the statement sum equals add 1, 10, 100 is calling the function add with these 3 values 1, 10, and 100. And in Python, what happens is that 1, 10, and 100 are each objects. And as we call the add function, the 3 arguments p, q, and r are bound to each of those 3 objects. The function then executes and returns yet another object, and that object is bound to the variable sum. Here's another example of a function. This time we've got a function that doesn't actually return any values, so it doesn't have a return statement, and rather than calling this function within an expression, we're simply calling the function as an executable statement, much as you would a void function. We're declaring some variables outside of the function and then referring to those variables inside the function. Python is just a block-structured programming language, as are many other current programming languages. So in Python, you can declare variables in an outer scope and then refer to those variables within an inner scope, as you might expect. Here is a further feature of the syntax. We're declaring 3 variables a, b, and c, all within the same assignment, and then assigning those 3 variables to objects representing the values 1, 10, and 100, respectively. We're then defining a function when we execute this statement, and the definition of the function is going to add the 3 variables together, a, b, and c, referring to these global variables, and then printing out the result, the value of the sum. So when we finally call the print sum function, you can see the value of 111 being printed out. As well as being able to manipulate integers and Boolean values and floating point values, Python also has lists. Lists are very, very important in Python. Lists are a bit like arrays in other languages, only they're rather more general. If some of you happen to know System Verilog, lists are quite a lot like queues within System Verilog. So here's an example of a list, square brackets 1, 2, 3. So a list is simply a list of objects of any type. So here we have a list of 3 integers. A is a variable. So when we execute the assignment a equals list 1, 2, 3, we're creating a new list and then binding the variable to that list. And because a list is a value, it's an object like any other value in Python. Then we're printing out the value of A0. Here we're using the subscript operator, square brackets 0, to pick out the value of the first item in the list. So lists or arrays in Python are always indexed from the value 0, just as they would be in C. So A square bracket 0 is the value 1. Lists in Python can consist of values of any type. So here we have a list where the first item is an integer, then a Boolean value, then another list, the list 1, 2, 3, and finally a string. So if we were to print out the value of B, we would see this nested list printed out, where the third item in the list is another nested list, 1, 2, 3. So in Python, you can nest lists and indeed any other data structures ad infinitum. We can also build slices of lists, which can be very convenient. So a slice actually picks out multiple values from the list, and the index of a slice is analogous to the index of the range function. We have a start value, a stop value, and a step value. So the slice B0:2 is going to pick out two elements from the list B, the first element and the second element, the element at index 0 and index 1, which is of course 1, true. So putting together functions and lists, here's a function that returns a list. So the def keyword introduces a new function definition called sum and diff. This function has two arguments, a and b. Colon indicates that the next line is going to be indented. We then have a return statement to return a value from the function, and the function actually returns a list that consists of two integer values, a plus b and a minus b, the sum of the difference. Then we're calling this function, sum and diff, within an expression, passing in two arguments. So a gets bound to 7, b gets bound to 4. Sum and diff executes and returns a list. That list is an object, and the variable x gets bound to the object returned from the function call. We could then, for example, print out the type of x, where type is another function that's built into Python. And type x is going to return a string that's going to describe the data type of the object to which this variable is bound. And the string in this case will be open angle brackets class list. So you can see here that Python is telling us that a list is an object of type class list. We could also print out the value of the list. So if we print x, we'll see the list 11,3 being printed out. We could also have chosen to print out the first element of the list, which will ultimately be the value a plus b. So if we print x0, we see the value 11 printed out, 7 plus 4. As well as lists, Python supports another kind of data structure, the dictionary. Dictionaries are quite common in contemporary programming languages. In Perl, a dictionary is known as a hash. In System Verilog, a dictionary is known as an associative array. In other languages, dictionaries might be known as sparse arrays. So in other words, a dictionary is like an array where only some of the elements of the array are actually populated. So each element of the dictionary has a value and a tag or key to indicate which particular element we're talking about. So here we've got a dictionary that consists of 3 items, an item Tom with the value 32, Dick with the value 58, Harry with the value 28. So the keys in this case happen to be strings and the items happen to be integers. We could then print out all of the keys of our dictionary by writing a for loop, such as for k in ages.keys. So remembering that Python is object-oriented, keys is a method of our dictionary object that returns all of the keys within the dictionary. And all of the keys in the dictionary actually turn out to be a list consisting of Tom, Dick and Harry. So k is going to be bound to one of 3 strings in turn. And when we print out the value of k, we're going to see Tom, Dick and Harry, and if we then use that key to index our dictionary, we'll see the values 32, 58 and 28 appearing as the print statement's executed. As you might expect, we can delete items from dictionaries, we can insert new items into dictionaries. And there's a number of methods available for manipulating dictionaries. Instead of returning keys, which returns a list of all of the keys in the dictionary, ages.items returns a set of 2 item lists, where each list consists of a key and the corresponding value. So each time we spin round this for loop, K is going to be set to the next key in the dictionary, such as Tom. V will be set to the value corresponding to that key, such as 32. So in this case, when we call print KV, we're going to see again each of the keys and the corresponding item being printed out. It's also very, very straightforward to take existing Python code and reuse it in other Python scripts or programs. And you do that in Python using so-called modules. So a module is simply a file containing Python code that's named with a particular convention. And the convention is very simple. You give the file name, the file extension .py. So spam.py is a Python module named spam that contains some regular Python code. So here we've got 2 Python modules, spam and eggs, that both contain a function of the same name. You then import Python modules into other Python programs using the import statement. So import spam simply imports the contents of the spam module into our current module. So here we're importing spam and eggs into the same module. We've imported 2 functions of the same name from 2 different modules, but we disambiguate those functions by actually prefixing each of the functions with the corresponding module name. So when we call the function spam.fn, it's going to print out spam, eggs.fn will print out eggs. There's a variation on the import statement that allows you to import specific definitions from existing modules so that we don't need to prefix those definitions with the module name. So if we say from spam import fn, that allows us to call the function fn directly rather than writing spam.fn. Of course, if we were to use this trick to import multiple functions from multiple modules where the names happen to clash, we wouldn't be able to call them unambiguously. So there's yet another trick. As you import a name from a module, you can choose to rename that definition as it's imported by writing something like from eggs import fn as fn2. So now if we call the function fn2, that's actually going to be implicitly calling eggs.fn. Python also supports packages. Packages are simply fancy modules. What you can do is to organize a set of modules hierarchically into a big directory structure. So mod 1, mod 2, 3, 4, 5, and 6 are simply Python modules organized into a directory structure. And the import statement then reflects the corresponding directory structure. So we might, for example, import top.part2.mod6, where mod6 is a particular Python module that happens to be nested at this point in a directory structure. We could then call a function top.part2.mod6.fn. Or if we want to avoid typing out this extended, rather verbose prefix, we could use the from import trick. So we could say from top.part2.mod6 import fn and then call the function fn directly. So again, mod6 is the name of a Python module. Top.part2 is simply reflecting the directory structure that contains that Python module. Finally, in this tutorial, Python supports the idea of a context manager. When you start diving into machine learning code, you might well bump into this language construct with. The with construct signifies the usage of a context manager. So in this example, we're saying with open spam.txt as file, do such and such. So here we're using a context manager in order to open a file. A context manager isn't doing anything that's a big deal. All a context manager is doing is allowing us to execute setup code and tear down code in a very, very reliable way. So associated with any context manager, wherever you see the with keyword, there'll be some setup code that makes sure that some list at the top, and some teardown code that's always executed at the end of this block of code to make sure that something is being properly torn down at the end. So in this case, we're using the context manager to control the opening and closing of a file. So the top of the context manager will make sure that the file is properly opened, and then at the end of the context manager block, the file will be nice and cleanly closed. So let's revisit that Keras model that we saw earlier in this webinar. The first couple of lines of code were actually importing the names of classes from some predefined modules within the Keras package. So you can now see that Keras is the name of a package, models and layers are Python modules, which ultimately implemented as Python code within .py files, and we're importing 3 specific classes. The line model equals sequential is then calling a constructor. So sequential is a class in the object-oriented programming sense. We're calling its constructor, which will construct an instance object, and we're then binding a new variable model to that instance object. Model.add is then calling a method of the object to which this variable is bound and passing an argument to its constructor. And in each case, the argument to the constructor is an object that's actually being created by calling another constructor. So activation is also a class. We're calling the constructor of the activation class with an argument. You can see here some of these arguments are being passed by position, like the string softmax. Other arguments are being passed by keyword. So dense, open parenthesis, units equals 10 is simply passing a keyword argument to a constructor that's being used to construct an object, which in turn is being passed as an argument to another method, a method of the object to which this particular variable is bound. Then here we are calling another method of our object, passing in some further arguments as keywords. The keyword argument metrics has a value that's actually a list, where that list happens to be a list containing a single element. Then here we're making another method call and yet another method call. This method call model.evaluate actually returns a list, and here we're using the subscript operator to select the second item from that list, the item with subscript 1. Remember, lists are always subscripted starting from 0. So after that Python mini tutorial, I'm now going to describe one of the most useful packages in Py, the NumPy package. The NumPy package is used as the foundation for a lot of scientific computing in Python, and it's also used as the foundation for many of the machine learning libraries in Python, libraries such as TensorFlow. So let's take a look at NumPy. Here's some code that you might well find on the web if you start browsing around the TensorFlow documentation. This is actually a fragment of a TensorFlow model that you can find on the web. It's made available under the Apache license. So if you actually want to make use of the code that you see on the slides here, you'll need to sign up to the terms of the Apache license under which it's distributed. In the code, the banner at the top of the Apache license you can see is written as Python's single line comments. And then we've got a Python doc string used down here. So here we've got a mixture of one-line comments and doc strings. Here's the URL of this particular code, incidentally, if you want to look it up for yourself. Next, we've got some import statements. So here we're saying from module future, import print function, and so on. The name here, double_future_, is a built-in property. Built-in properties in Python all start and end with $_. So whenever you see a $_ before and after a name, you know that's some property that's built into the Python language. The module future is a very special module that allows us to access features implemented in later versions of the Python standard, which is a bit mind-boggling. So in Python, you can actually import things from the future. Scary, huh? So the idea is that you might be using the Python 2 compiler, but you might want to use features that weren't added until Python 3. And you can actually do that because some of the later Python features have been retrofitted into earlier versions of the Python compiler, which is a really cool feature. ports. So for example, import TensorFlow as TF. So TensorFlow is the full name of the TensorFlow package, and what we're doing here effectively is renaming it as TF, which is a convention that's typically followed. Then we're defining a new variable flags and set it to have the value none. None is a special value in Python, and it's typically used to designate the default value of an argument or a variable. So if you see the value none being used, it means that particular value or variable is just being set to some default value. Here we've got a function main. Main isn't a special keyword in Python. We're just defining a user-defined function with a single argument. And for that single argument, the writers of the code have chosen to use an underscore character. An underscore character is a special name for a variable that you can use when you are not actually interested in the value of the variable. So an underscore is effectively a placeholder that says, here we've got a function with one argument, but we're not going to use the argument. Then in the body of the code, we've got a comment, we're assigning a variable, and then we're writing some code to create our neural network model. You can see here straight away some lists. So 784,10 is a list. I'm not going to say any more about this code at this point in time because we need to learn some NumPy first. I'll then come back at the end of this particular section and we'll pull apart this code and see in a little bit more detail what's really going on. So, NumPy. NumPy is a third-party package added onto Python that supports scientific computing. In particular, NumPy provides you with a multi-dimensional array object, and that multi-dimensional array object supports matrix manipulation, it supports linear algebra, and it supports all sorts of other common operations that you might want to do on large collections of numbers, such as machine learning, for example. So if we walk through this code, first of all, we're importing the NumPy module, renaming it as NP. That's a convention, but a convention that's almost always followed. We're then constructing a NumPy array. So np.array is a class. We're calling the constructor of that class. We're passing as a constructor argument a Python list. So here we've got a 1D NumPy array. If we print out the value of A, you can simply see the value is printed out as a one-dimensional array. We can use subscripting on our NumPy array, so array subscript 0 is just the value 1. We can also construct 2D arrays in NumPy. Indeed, we can have multi-dimensional arrays with any number of dimensions, otherwise known as tensors in mathematical language. So here we're building a NumPy array, and as the constructor argument, we've built a list of lists. 1, 2, 3, 4, 5, 6. And if we print out the value of A here, you can see it's printed out in a format that suggests the rows and columns of a matrix. Because NumPy is intended for matrix manipulation, NumPy effectively understands a 2D array object as a matrix, so it prints out the value in row-column format for us. NumPy arrays are structured in a particular way. A NumPy array has a number of dimensions, 2 dimensions in this case. It has a size, which is the total number of elements in the array. It also has a shape, which is the number of elements in each dimension. So here we've got an array that contains 2 rows and 3 columns. So its shape is 2, 3. You might notice that 2, 3 is written in parentheses as opposed to square brackets. Technically, in Python, this indicates a tuple as opposed to a list. A tuple is simply a read-only list. So a tuple is like a fancy list where we're not going to change the definition of the list. So if you want a list where you're not going to change the definition of the list after you create it, you can wrap that up in parentheses rather than square brackets, and it becomes a tuple. We also have the data type of each element in the NumPy array. In general, lists in Python can contain mixed data types. Within NumPy arrays, however, all of the elements have to have the same data type. So in this case, the data type of each element in the NumPy array is int32. multi-dimensional arrays. So A1, 0 means the element at row 1, column 0, which is element 4. We can also include slices within either or both of the dimensions. So here we're selecting row 0, column 0, colon 3. So we're picking row 0, the first row, and all of the elements in that row, the elements 1, 2, 3. As a shortcut, if you know you want to select all of the elements in a particular row or column, you can just use a colon. So A square brackets colon, comma 0 means we're selecting all of the rows and column 0, which will be 1, 4. So we end up with a one-dimensional vector containing the elements 1 and 4. So this kind of slice notation, combined with shortcuts such as a colon, can be very convenient. NumPy provides you with a wide range of different interesting ways of initializing NumPy arrays. So here we've got a shortcut way of building an array that is pre-populated with zeros. So np.zeros built as an array of zeros, and the argument to this zeros function is actually specified as a shape, a tuple of 2 elements. So here we're ending up building an array consisting of 2 rows and 3 columns, each populated with zeros. And the default data type here is actually going to be 32-bit floating point numbers, because that's just the way NumPy works. There's also a quick way of building an array which contains a sequence of values, which can be very handy for building toy examples or generating test data. So np.arange4 is building as a NumPy array consisting of 4 elements with the values 0, 1, 2, and 3. We can also take an existing NumPy array and reshape it. And this is particularly useful if we're trying to manipulate the data that we're going to be using to solve a machine learning problem. So if you're trying to read in your own data from files and then manipulate that data to put it through a package like TensorFlow, you're typically going to need to do some reshaping on that data. So np.arange1, 25 is going to give us a one-dimensional vector consisting of the 24 values 1 through to 24. And then the reshape method reshapes that one-dimensional vector into a 3-dimensional array consisting of 2 blocks of 3 rows of 4 columns. Associated with NumPy is another package, matplotlib, and matplotlib gives you a huge range of predefined functions to help plot or visualize your data. Here I'm just giving you a taster of some of them. So here we're making use of the pyplot module in order to make a 2-dimensional plot of a 2-dimensional NumPy array organized as some sort of color map. So here, np.random.rand 10,10 is constructing for us a 10 by 10 matrix, where each element of that 10 by 10 matrix is initialized to a real number in the range 0 to 1. We're then using plot.imshow to actually build a 10 by 10 plot that we're then displaying using the plot.show function. This is what you'll see printed out. And just to give you a taster of some of the other plotting features that are available, you can plot a histogram in just a few lines of code using pyplot. So here again, we're importing a Python module, renaming it to PLT, generating a standard normal distribution of numbers with a single line of code, then plotting that as a histogram with 25 buckets. Similarly, you can do line plots in an extremely straightforward way, making use of the pyplot module. There's a massive range of functions available. And this is, again, really just giving you a taster of some of the amazing things that you can do in the Python world. Almost anything that you think you should be able to do in Python, you can do. If it's something that you expect any programming language should have, chances are Python does have the feature that you're already looking for. And because Python itself is such a compact language, the feature that you're looking for might not be in the Python language itself, but it probably will be in the Python standard library. And if it's something at a slightly higher level, then again, somebody will have thought of it and have done it So, for example, if you fancied reading in an Excel spreadsheet into Python, somebody's done that already, and you can simply use the third-party package for reading in the Excel spreadsheet. In fact, there are many of them, and the same goes for any other problem that you might think of. Anyway, enough enthusing about the Python community, back to NumPy. The NumPy array supports any commonly used matrix manipulation that you might think of. For example, here we're creating a 3x3 matrix by starting off with a vector of 9 values and then reshaping those 9 values, 0 through 8, to have 3 rows of 3 columns. If we then write A plus A, what we're doing is adding a 3x3 matrix to itself, and that's going to do an element-wise add. So each element of the matrix is added to itself. So 8 plus 8 equals 16. Or if we write A times A, we're doing an element-wise multiplication of the element in the matrix. 8 times 8 equals 64. We could also combine a NumPy array with a scalar. So again, A is our 3x3 matrix, and if we write A plus 1, A is, again, if we're going to think it through technically, A is just a Python variable that's bound to an object where the type of that object happens to be a NumPy array, and the NumPy array happens to be a 3x3 matrix. And to that, we're adding a Python integer object. So what will happen ultimately if we just add a 1 to each element in the matrix, because that's what NumPy is doing for us. We could take that further. So here we're multiplying each element of the 3x3 matrix by 4 and then adding 1. So if we take the final element 8, we're multiplying 8 by 4 to create 32 and then adding 1 to create 33. Python NumPy arrays also support broadcasting. Broadcasting is a really cool feature, but it might be a little confusing if you haven't seen it before. So again, back to our 3x3 matrix A. Suppose we have A, which is a 3x3 matrix, and B, which is a 3-element vector. And suppose we print out the value of A plus B. So here we're trying to add a 3x3 matrix to a 3-element vector. What's going to happen in that case, where we have our matrix plus our vector, is that the elements of the vector are going to be broadcast to have the same shape as the matrix A that we're adding them to. So the row 10, 20, 30 is going to be replicated to create 3 rows, each with the value 10, 20, 30. That's the implicit broadcast operation. So we then end up doing an element-wise add on these 2 matrices, the explicit matrix and the matrix that was implicitly created by the broadcast operation, to create a final 3x3 matrix. So now, finally, let's revisit a TensorFlow model and see if we can figure out what's going on. So here we've got a comment. Then we're constructing an object and binding that to a variable, and the constructor here is actually designating the data type of each element within a NumPy array. The TensorFlow module, or rather the Python front end to TensorFlow, is actually built on top of NumPy. So although we don't have any explicit references to NumPy, all of the objects that were created here are actually layered on top of the NumPy package and have many similar behaviors. So here in this case, this TensorFlow variable is effectively a NumPy array, and ultimately we're building a NumPy array that's populated with zeros, and this list here is specifying the shape of that underlying NumPy array. You can see here we're creating an array of 784 rows by 10 columns, ultimately a 2-dimensional NumPy array. Here we've got a NumPy vector consisting of 10 elements. Then here, tf.matmul under the hood is using NumPy to perform a matrix multiplication on a pair of matrices. And then when we do the plus b, we're performing an addition of a matrix to a vector. And that under the hood is using precisely that broadcast mechanism that I talked about on the previous slide. Then moving further through our TensorFlow model, we've got a for loop that says for underscore in range 1000. So you know now that range 1000 is simply generating 1000 integers in the range 0 through to 999 inclusive. are being bound to a variable underscore, and the name underscore is being chosen here because this particular code doesn't actually explicitly make use of this variable. So we're effectively throwing away the value, which is doing something 1,000 times. Here, this function nextBatch is returning a list of two values. So the first element of the list is being bound to batch x's, the second element to batch y's. Then ses.run is calling a method of the object to which the ses variable is bound. We're passing to that function two arguments. The first argument is being passed by position. The second argument is being passed as a keyword argument, and its value is actually a Python dictionary. So here in curly braces, we have a Python dictionary containing two elements. The first element with key x has the value batch x's, and so on. Moving further through the code, with tf.session as session is simply an example of a Python context manager. So this context manager is being used to set up a TensorFlow session and to make sure that all the setup code and the teardown code is properly executed. Here we're making another method call to run something to initialize variables, then a for loop to step through all the values in a range. Here we're assigning a variable. This is a regular multiplication, a regular remainder on division. Shaped square brackets 0 is simply indexing into a list, selecting the first value of a list. And the list in this particular case is the shape of a NumPy array, and then we're subtracting batch size, which I guess is just an integer. Here we're assigning a couple of variables by indexing two-dimensional arrays. The first element is specified as a slice, offset through to offset plus batch size. For the second element, the raw colon means we're selecting all of the values in that particular dimension, as we saw earlier. Here we're assigning a variable feedDict with a value that happens to be a Python dictionary. So on the right-hand side here, we're constructing a new dictionary object and then binding that object to the variable feedDict. Here we're calling the method of the object to which the session variable is bound. We're passing two arguments to this function. The first argument is a list of three values. The second argument, the keyword argument, is passing in the value of a variable. This method run is then returning a list of three values, and we're assigning the three values of that list to three variables, underscore, L, and predictions. And the underscore again means we're actually throwing away the first of those variables. We don't care about its value because we haven't named it. We then have an if statement that's using the remainder on division operator borrowed from C, and a print statement. So during this webinar, I hope I've given you a few pointers as to the key features of Python that you're going to need to know about to get into machine learning, and hopefully given you some ideas about what you should be looking for to get further information. Indeed, if you want to learn Python, we at Doulos can help you. We deliver a 2-day Python training class, Essential Python, which will teach you all of the features that you need to know to start using Python if it's not really part of your day job. So if you want to be using Python as a scripting language or use Python just to help you do whatever it is you do during your day job, the Essential Python training class might be just what you need. So do check it out. At Doulos, we deliver training classes worldwide in a whole range of subjects, covering hardware design, hardware verification, embedded systems, ARM, and FPGA technology. So if you want to know any more, do check out our website, www.doulos.com. That brings us to the end of this particular webinar, but we're happy to stay on hand to answer your questions as long as you're asking them. So do feel free to continue to type in your questions.